When I was a kid, I always remember we would have like family over for big occasions, and we were always told to get out the silverware. We had the fancy utensils that were coated in silver that we could use. It was really the only time we were able to use them is like Christmas or Thanksgiving, but they were the fancy cutlery that we had in our house. You see, to have a pure set of silver cutlery would be really, really expensive. And so instead, we had what was called silver plated cutlery. Literally, it's just a piece of metal coated on the outside with silver. This is called electroplating. The way that we do this is we actually use electricity to plate or coat the outside of another material. We see this all the time. You may have like gold plated jewelry, you may have nickel plated things, you may have chrome plated metal on your car. There's lots of different ways that, or materials that we can coat substances with, but we all make them pretty much the exact same way using the method of electroplating. Electroplating is just an electrolytic cell, but designed to actually cause the reduction of a metal on top of another substance. So when we have electroplating, let's do some kind of example here. Let's say you want to electroplate an iron, so let's say like Fe, let's do like a fork with silver. I mean, you don't really want to have iron utensils. They're going to rust super fast. And if you coat it with some silver, you're going to have something nice and fancy to show off to all the people that are coming to your dinner party. And let's say you're an artisan, you want to do it yourself. So here's what you need to do. You need a container. Inside of that container, you are going to need the fork that you wish to electroplate. So you want it to look good. I mean, it can't just be any old fork that you're electroplating here. Although this may not be the best choice, but there you go. The other thing you need to do is you need to submerge it into a solution. That solution needs to contain the actual substance that you are hoping to electroplate it with, which in this case is silver. So we have an iron fork, but we need silver ions in the solution. So what does that mean? What that means is I need an electrolyte, and that electrolyte needs to have silver ions, and it's always best to pick something that isn't actually going to precipitate with any other substance. So silver nitrate is a pretty good bet here to use. What we need is to actually have those attach onto this iron fork that we have here. So we need this to actually supply electrons so we can have the reduction of silver on the surface. What that means is you need to connect your fork to an electrochemical cell. You need to connect it to an electricity source. And we need the electrons to flow into that fork. So that means you need to connect it to the negative side of a battery. What's going to happen then is as the electrons flow in, they're going to spread out in your fork, and that is going to cause the reduction of silver on the surface of the fork. Now, you have positive ions in the solution, negative electrons. Those positive ions are going to be attracted to your negatively charged fork. Then once they touch those electrons, they'll actually react into silver, and some of them will actually deposit on the surface of the fork. You need to actually use a conductive material to do this because you need the electricity to flow through. That's why you don't have like silver-plated plastic cutlery, because you literally can't do that. You can't get electricity to flow in it, so you can't get that to take place. Now here's the problem though. You have this substance becoming, or this solution becoming more and more negative. Basically, you also have these nitrate ions that are floating around in here they're not reducing or reacting, and the silver is, which means that the positive ions are going away, but the negative ions are still floating around. So you need to replace those positive ions with something. But if you replace them with anything other than silver, as the reaction takes place, they're going to deposit onto the fork, and then that's totally going to ruin what you're trying to do. Dinner party, over. So what you need is a solid piece of silver. So you need to take a solid chunk of silver like we all have laying around at home. And what's going to happen here is you're going to have that silver oxidize into silver ions as it loses electrons. So basically, the silver solid is going to lose electrons. That's going to create silver ions in the solution. And over the course of this reaction, they can continue to build up on the surface of your fork. The only thing is you need to lose those electrons, and you need to lose them back to the electrochemical cell to complete the circuit. So you need to connect this part to the positive side of your electrochemical cell. So what do you need to actually have your own silverware made by you? Well, you need a conductive material connected to an electrochemical cell. It needs to be connected to the negative side of that battery, or the negative side of the electrochemical cell, so the electrons can flow in. You need a solution that has the ion you're hoping to reduce, and that is going to allow those electrons to flow in, have that reduction reaction take place right here, but you need to replace the ions with the same thing by having the oxidation reaction happen there. The electrons that are being lost in that oxidation reaction can go back and be gained in the electrochemical cell. The other thing we actually have going on in here is an anode and cathode. Remember, this is the site of reduction, and the site of reduction is the cathode. So the thing that you're actually electroplating is going to be your cathode. And in an electrochemical cell, that cathode is negative, or sorry, electrolytic cell. Electrolytic cells have a negative cathode, whereas an electrochemical cell has a negative anode. The other side, my silver bar here, this is the site of oxidation. And the site of oxidation is the anode. And in an electrolytic cell, the anode is positive. It should always be negative to negative, positive to positive. And so that's why we have it set up like this. You may notice I had iron, but there is no iron actually reacting at all. The only reason we have something like iron is because it's electrically conductive, and that allows this to take place. So this is the process that we use to actually electroplate everything. You hook it up to a battery, you make sure you have a substance to replace the ions that's connected to the positive side of your battery. You have a solution containing the ions that you're hoping to actually deposit, and that's all you need. So thanks for watching, and I will see you next time.